problems on solutions of system of linear equations. Before going to solve the problems, just I want to explain the important concepts of the problems. There are two types of linear equations: homogeneous system of linear equations. Second one, non-homogeneous system of linear equations. Now, if the system has solution, then it is consistent, otherwise inconsistent. Means if any system has solution, means that system is called consistent system. If the system has no solution, means the system is called inconsistent. Now I am writing here separately non-homogeneous system of linear equations and homogeneous system of linear equations. Solutions. What type of solutions exist for this? First of all, I am reading out here non-homogeneous system of linear equations. Remember, for non-homogeneous system, there are three types of solutions exist. One is unique solution. Second one, infinitely many solution. Third one, no solution. When should I get unique solution, infinitely many solution and no solution? We have some conditions. If rank of A equal to rank of augmented matrix, rank of A by B equals to n, then it has unique solution. The system has unique solution. A by B means the coefficient matrix and the last column matrix B matrix. If you are writing, the total matrix is nothing but augmented matrix A by B. That's why A matrix, after completion of A, you add B matrix, means that is B matrix. Every time mostly we are getting column matrix. That column matrix you add it, then that full matrix is nothing but augmented matrix, that is denoted by A by B. Once again, for that unique solution, rank of A equal to rank of A by B equal to n. N is nothing but number of unknown variables. You have to calculate these variables only, unknown variables. All are equal, then we are getting unique solution. Second one, rank of A and rank of augmented matrix both are equal and this number is less than the number of variables, less than n, then we get infinitely many solution. Third one, rank of A not equal to rank of A by B, then system has no solution and this system is called inconsistent. Now this is like this. These are the solutions for non-homogeneous system of linear equations. Once again, unique solution, infinitely many solution and no solution, and I give the conditions for these three solutions. Next, what type of solutions are available for homogeneous system of linear equations? There are only two types of solutions. One is zero solution, other one is non-zero solution. The zero solution is also called trivial solution. Non-zero solution is also called non-trivial solution. And one thing, important point, very important point, every homogeneous system is consistent. Means every homogeneous system has solution. This is very important. Means it is a homogeneous system is not, means it compulsory it has solution. It is not consistent, right? It is not consistent means we won't get inconsistent system. Once again, every homogeneous system is consistent, means it has one solution, it has zero solution. Conditions: when should I get zero solution and when should I get non-zero solution? Means when should I get only zero solution? Some systems has only zero solution. For every homogeneous system, there exists one solution, that is zero solution. First condition, rank of A equal to n, then the system has only zero solution, no other solution. Next, suppose rank of A is less than n, the system has non-zero solution also. Means the system already contains zero solution and as well as non-zero solution. Another solution exists, that solution is called non-zero solution. For this one, the another condition, if it has non-zero solution, determinant of A equal to 0. If determinant of A not equal to 0 means only zero solution. By according to determinant, we can explain rank of A equal to n, it has zero solution. Rank of A is less than n, it has non-zero solution. These are the concepts, right? Now here, non-homogeneous system means RHS side, at least one element we will get it, means one number definitely we will get it, means all are not equal to some, at least one number not equal to 0. Suppose RHS side, if the all elements are zeros, all the numbers are zeros, means x plus y plus z equal to 0, 2x plus 3y minus z equal to 0. If you got equal to 0 without any real number, right, then that system is called homogeneous system. Means every coefficient is B matrix is 0 matrix. If B matrix is 0 matrix, then that is nothing but homogeneous system of linear equations. These are the important points to solve the system of linear equations, right? First problem, a non-homogeneous system of linear equations. Solve the system of linear equations. X plus y plus z equal to 4. Second equation, 2x plus 5y minus 2z equal to 3. X plus 7y minus 7z equal to 5. Now once again I am writing that given system of linear equation. Here write those three equations. These are the three equations. The above system of equations can be written as Ax equal to B. A is coefficient matrix 1 1 1, 2 5 minus 2, 1 7 minus 7. X is variable matrix x y z. B equal to 4 3 5. Now consider augmented matrix. If you want to solve the system of linear equations, every time already I told you, consider augmented matrix. A by B equal to 1 1 1 4, 2 5 minus 2 3, third row 1 7 minus 7 5. Convert this matrix into echelon form. To get that echelon form, R2 changes as R2 minus 2R1, R3 changes as R3 minus R1. 1 1 1 4, 2 minus 2 0, 5 minus 2 3, minus 2 minus 2 minus 4, 3 minus 8 minus 5. In the same way, third row 0, 6, minus 8, 1. Now using second principal diagonal element, you make below element as 0. R3 changes as R3 minus 2R2. Then matrix becomes as 1 1 1 4, 0 3 minus 4 minus 5. Third row 0 0 0 11. Now from the first three columns means matrix A. Number of non-zero rows in A equal to 2. That is rank of A equal to 2. Number of non-zero rows in A by B means from first four columns equal to 3. Therefore, rank of A not equal to rank of A by B. The system has no solution and it is inconsistent system. Solve the system of linear equations. X plus 2y plus 3z equal to 1. 2x plus 3y, 8z equals to 2. X plus y plus z equals to 3. The above system of equations can be written as Ax equal to B, where A equal to 1 2 3 2 3 8 1 1 1. X is variable matrix unknown with unknown variables. X equal to x y z. B equal to constant matrix with 1 2 3. Now consider the augmented matrix. A matrix you combine with column matrix, means B also we are adding in the last column. Augmented matrix A by B equals to 1 2 3 1 2 3 8 2 1 1 1 3. Now you convert this augmented matrix into echelon form. Means in the second row first element should be 0. In the third row first two elements are zeros. Now for that purpose, using the principal diagonal element, we can convert the below the principal first principal diagonal element, you make elements as zeros. For that purpose, R2 changes as R2 minus 2R1, R3 changes as R3 minus R1. Then 1 2 3 1, 2 minus 2 0, 3 minus 4 minus 1, 8 minus 6 2, 2 minus 2 0. Now R3 minus R1, 1 minus 1 0, 1 minus 2 minus 1, 1 minus 3 minus 2, 3 minus 1 2. Now from the above matrix, again already below the first principal diagonal element I got two zeros. Anyhow I need in the second row first two elements are zeros. Then using second principal diagonal element, you make below that element as 0. For that purpose, R3 changes as R3 minus R1. Then first two rows are same, 1 2 3 1. Second row 0 minus 1 2 0. Third row 0 0 minus 0 0. R3 minus R2 here. 0 minus 0 minus 1 minus minus 1 means it becomes that element minus the two elements are same, 0. 2 minus 2 minus 4, 2 minus 0. Now this is in echelon form. Number of non-zero rows is 3. Therefore rank of A by B equal to 3. Number of non-zero rows 3. Number of non-zero rows in A is 3. Rank of A equal to rank of A by B equal to 3. the above system has unique solution. Because rank of A equal to rank of A by B equal to 3, the above system has unique solution. Now solve this system. From the last echelon form matrix 1, 2, 3, 0, minus 1, 2, 0, 0, minus 4, x, y, z equals to 1, 0, 2. Then you multiply x plus 2y plus 3z equal to 1, first row, first column, minus y plus 2z equal to 0, minus 4z equal to 2. Then minus 4z equal to 2 means minus 2z equal to 1, z equal to minus 1 by 2. Next, substitute z equal to minus 1 by 2 in above equation. Minus y plus 2 into minus 1 by 2 equal to 0, minus y minus 1 equal to 0, minus y equal to 1. This implies y equal to minus 1. Now substitute y equal to minus 1 and z equal to minus 1 by 2 in the equation. In the first equation is x plus 2y plus 3z equal to 1, x plus 2 into minus 1 plus 3 into minus 1 by 2 equal to 1. Then x minus 2 minus 3 by 2 equals to 1, x equal to 9 by 2. Therefore, variable matrix x equal to 9 by 2 minus 1 by 2 is the unique solution.